My name is Tony Coverdale and I chair the Salford Brass Mill project. The rise and fall of the Avon Valley brass industry is the second of 4 presentations on the topic. In part 1, I described the industry's origins in the early 1700s, focusing on the activity of the Bristol Brass Company. In part 2, I continue the story, addressing the developments made by the company for the drawing of brass wire and the rolling of sheet metal. I go on to describe the creation of a rival company, the Walmley Brass Company, and the innovations made by the company's director, William Champion, most notably the smelting of zinc. The presentation also describes how James Emerson, Champion's technical manager, established his own company in the late 1700s and continued to smelt zinc using Champion's methods into the early 1800s. One particular use of brass is also explored, namely the manufacture of pins, for which Champion created a purpose-built factory. The presentation concludes with the decline of the Bristol Brass Industry in the early 19th century, as a consequence of a fall in demand for hollowware following the abolition of the slave trade, and competition from Birmingham-based industrialists. In part 1, I described how the Bristol Company had been founded in 1702 at Baptist Mills, on the River Frome to the north of Bristol, where brass was made by alloying copper and zinc. The Brass Company initially acquired copper from a smelting plant at Conham on the River Avon, which had been established by Abraham Elton in 1696, but they later increased their supply by the creation of their own smelting works downstream of Conham at Crews Hole. By 1721, the company had 4 battery mills in operation, at Down Mill on the River Chew in Keynsham, Woodborough Mill, also on the River Chew, Weston Mill on the River Avon just outside Bath, and Salford Mill, again on the River Avon. In this presentation, I will address the acquisition of Avon Mill at Keynsham and its use as a brass wire mill, the rival Walmley Company with associated copper smelting at Kingswood and battery at Kelston and Bitton, zinc smelting by James Emerson at Hannam, and the rolling of brass sheet at Salford. So turning first to the Keynsham wire mill. Wire was in demand for a number of reasons. Wire was needed for the manufacture of carding combs used in the woolen industry. Carding is the process of untangling and intermixing raw wool to produce a continuous web called a sliver prior to spinning. The process was carried out using a pair of carding combs, consisting of handheld pads in which were set numerous pins. The pins needed to be stiff and also made of a material that did not stain the wool. Brass was eminently suitable for this purpose, but material of the right quality had to be imported from the continent. Wire was also needed to manufacture pins. As shown in the photograph, pins were not just used in preparation for sewing, but clothes were worn held together with pins. The supply of these consumable items was therefore an integral part of the textile trade. Bristol gained entry into the wire industry through a partnership with the Esher Brass Wire Company. A factory had been established at Esher in Surrey for the manufacture of brass wire in 1649, described as the only factory of its kind in England. However, in 1709, the Esher Company was in financial difficulty, and a merger was sought with the Bristol Brass Company. The two companies formed a joint venture called the Societies of Bristol and Esher for making brass, battery and brass wire. Production initially continued at Esher, but benefit was seen in moving the wire drawing factory to Bristol. Avon Mill was adapted for this purpose in the 1730s, with the Esher factory being closed in the early 1740s. The Keynsham wire mills, as Avon Mill became known, was capable of rolling cast brass slabs into strips, slitting the strips into strings and drawing the strings into wire. When the Swedish traveller and diarist Reinhold Angerstein visited Keynsham in 1754, he recorded, "By the town of Keynsham, 5 miles from Bristol, on the way to Bath, there are 2 specially built brass works, belonging to the Bristol Brass Wire Company, comprising rolling and slitting mills for brass wire. There is also a wire drawing mill here." Keynsham wire mills were still in operation in the early 20th century, seen here on the 1902 Ordnance Survey map. The site comprised 2 works, the newer upper works, powered by steam machinery, constructed in the 1830s, and the older lower works, powered by water wheels, constructed in the 1730s, with the late 18th century manager's house, Avon House, located between them. A dimensioned plan of the lower works has survived, dated May 1828. The plan shows the layout of the original works, which drew upon the experience gained from Esher. The works are powered by 8 water wheels in 3 workshops. The plan also shows the footprint of a large cone which dominated the site. This may have originally been part of a cementation furnace or a zinc smelting furnace, but by 1828 it housed 2 annealing ovens. The plan also shows a building described as the Old Mill. This building still exists and is now a Grade 2 listed building incorporated into the modern Brass Mill pub. This is a photograph of the building described as the Old Mill in 1828, taken in 2018. The building is constructed on top of a large arched culvert into which the tail races of 5 of the water wheels discharged before rejoining the river. Copper slag blocks have been used in the construction and repair of the building, emphasising the association with copper smelting. This is a photograph of the site of the Keynsham Wire Mill, taken in 2014 from Avon Mill Lane, with the Great Western Railway in the foreground. And this is the same view in 1904, with a large conical brick chimney clearly visible in the background. We are fortunate in having a number of photographs of the wire mill taken around 1925 by Alfred Davis, the last manager of the company. This is a view from the roof of an outbuilding looking up the site, with the cone in the foreground and the manager's house, Avon House, with its distinctive clock tower in the background. Avon House still stands, restored in 1985, with its distinctive clock tower, but now minus its clock. The house is also listed Grade 2. Copper slag blocks can be seen used in the construction of the walls, again showing the link between the Brass Company and copper smelting. And this is a view from the clock tower looking down the site. Again, its dominant feature is the large brick cone. The cone was demolished in the 1930s and the surrounding buildings in the late 1940s, but the row of buildings on the left remain in part refurbished as the pub landlord's accommodation. And the old mill described earlier can be seen behind and to the right of the cone. And lastly, this is an upstream view from the mill showing the head race as it enters the mill to drive the rolling and wire drawing machinery. The manufacture of wire was a multi-stage process, the intermediary products being slabs, strips, strings and eventually wire of various thicknesses. The first step was to cast the brass into a long, narrow slab in an elongated mould. The slab was then rolled to produce a long coiled strip approximately 10 centimetres wide and 2 millimetres thick. Coiled strips were produced by passing the slabs through a rolling mill, a number of which can be seen stacked against the rolls in the centre right foreground. The upper and lower rolls were each driven by a separate water wheel, the large wheels in the background being a reversing gear to enable the rolls to contra-rotate. The 3 windows above the rolls looked out over the head race. And the rolling mill was located here, with the wheels either side driving the upper and lower rolls. The upper roll was driven by this water wheel via the reversing gear. The coiled strips were then taken to the slitting mill, where the strips were slit into multiple strings. Slitting was carried out in a separate workshop, which housed a slitting mill driven by a single water wheel. And the mill comprised 2 slitting rolls geared together to turn at synchronous speed. The strings were then passed through a die called a whortle plate to produce thick wire, and the process repeated by drawing the wire through ever-decreasing smaller dies to produce the thickness of wire required. The wire was cold drawn, causing it to work harden, and requiring it to be periodically annealed to restore its ductility. The process was started by hand, but then transferred to a water-powered capstan to draw out the long coil of wire. The wire was drawn on a bench in a specially constructed workshop. Each bench consisted of a power-driven capstan to draw the wire, a die block called a whortle plate through which the wire was drawn, and a freewheeling reel called a swift to hold the feed material. The bench also had a hand-operated roll and pincers to enable a new coil of wire to be set up. And the wire drawing workshop was on the upper floor of the mill and contained multiple benches driven through drive shafts in the floor, turned by a water wheel on the lower level of the mill. Wire drawing was carried out in this area of the mill, with multiple benches being driven by a single water wheel. We turn now to the Walmley Brass Company, established in 1746 by William Champion. William was the son of Nehemiah Champion, the technical director of the Bristol Brass Company and nephew of Richard Champion, a shareholder in the Bristol Company. Nehemiah had been responsible for many of the technical developments of the Bristol Company, taking out patents on annealing and improved brass melting in 1723. William followed in his father's footsteps, touring Europe in the 1720s to observe the art of brass making, and returning to become a junior partner in the Bristol Company in 1730. William's major technical breakthrough was the smelting of zinc, for which he obtained a patent in 1738. William broke away from the Bristol Company in 1746, founding a rival company, the Walmley Brass Company, for which he obtained finance from a number of investors, one of whom was Sampson Lloyd, an ironmaster from Birmingham who was later to found Lloyd's Bank. William's aim was to create an integrated facility on one site that incorporated the full capacity of the Bristol Company of copper smelting, brass alloying, brass battery, wire drawing and annealing, with the additional capability of zinc smelting and a pin factory. The integrated facility was built on a large site in Walmley. But as demand grew, the company expanded, and an additional complex for smelting copper was built at Kingswood in 1761, described as the Kingswood Cupola, plus battery mills at Bitton and Kelston. Champion replicated the Bristol Company's copper smelting capability with the erection of smelting furnaces at Walmley and later Kingswood, Angerstein reporting having observed 15 furnaces at Walmley in 1754, which, as recorded in an inventory of the company in 1761, rose to 22 furnaces with the addition of the Kingswood Cupola. Champion also replicated the brass alloying furnaces at Baptist Mills, with the construction of 12 brass furnaces at Walmley, rising to 15 furnaces in 1761. And the battery mills were also replicated, Angerstein observing 1 battery mill at Walmley in 1754, rising to 5 battery mills by 1761. Champion had ready access to coal at Walmley, but the site posed an obstacle of a supply of water to drive the battery and wire mills. The System Brook flowed through the site, but was too small to power the mills. The immediate solution was to dam the brook to create a reservoir of water of sufficient head to power the mills. But the mills could only be used intermittently, as once the head of water had been exhausted, it would take time for the reservoir to be refilled. Champion overcame the problem by installing a fire engine at the outfall of the mills to pump water back upstream into the reservoir. Angerstein produced this sketch of the fire engine in his travel journal of 1754. The engine was an atmospheric beam engine, of the type invented by Thomas Newcomen and patented in 1705. The engines were used principally for pumping water out of mines, the first practical engine having been installed in the Black Country in 1715. The engine at Walmley was erected in 1749 by Joseph Hornblower of Birmingham. The engines used a large amount of coal, but this was not an obstacle at Walmley, sited in the middle of the Kingswood coalfield. It should be noted that Boulton and Watt's engines did not appear until 1776, and Watt did not perfect his rotative mechanism until 1781. Hence, replenishment of water in a reservoir was the only practicable means of driving a mill using steam power available to Champion. The engine was removed in the late 1700s, but the engine house remained, seen in this photograph taken shortly before its demolition in 1967. The engine house can also be seen in this aerial view of the site, taken in 1945, when the site was in use by Haskins for making clay drainage pipes. Although much of the site was cleared in the 1960s, the distinctive factory and clock tower in front of the engine house have survived, and this is the focus of the next part of the talk. This was Champion's pin factory. Pin manufacturers were major buyers of the wire produced by the Bristol Company, with Gloucester being a centre of pin manufacture. Pins were made by a combination of in-workers, paid piecework for the manufacture of pins in a factory, and out-workers, making pins in the home, workhouses and sometimes prisons. Champion sought to increase his market share by the erection of a pin factory on the same site as his wire mills, cutting out the pin manufacturers and placing both the drawing of wire and the manufacture of pins under his direct control. The 18th century pin manufacturing process is described in the Systematic Dictionary of the Sciences, Arts and Crafts, published by the French philosophers Denis Diderot and Jean-Laurent d'Alembert in 1751. This plate from the dictionary shows the various stages in the process. The first step is to straighten the coiled wire as obtained from the wire mills. The coiled wire was placed on a capstan and drawn out between a series of stout nails on a bed plate. The action of drawing the wire between the nails straightened the wire and also worked the wire to induce stiffening by work hardening. The straightened wire was then of sufficient stiffness for use as pin shafts. The next step was to cut the straightened wire into the lengths desired for each pin. The pin heads were then made separately using a purpose-built coiler machine powered by a person turning a large hand-cranked drive wheel. The pin heads were made by coiling soft heading wire onto a mould wire. Each head was then individually cut from the length of tightly coiled heading wire. The separate pin shafts and heads were lastly brought together using a pin heading machine. A shaft was placed in a hollow die and a coil of loose wire placed on the exposed shaft. The head was then struck with a weighted headed punch, which mechanically clenched the head to the shaft. The economist Adam Smith used the division of labour in pin manufacturing as an example of industrialisation in the introduction to his groundbreaking work, The Wealth of Nations, published in 1776. Smith observed that there were about 18 distinct operations in the making of a pin, and with 10 men in a manufactory, they could make upwards of 48,000 pins in a day, whereas working individually, they could not have made 20 pins in a day. As recorded on the reverse of the recently withdrawn £20 note, Smith summarised the analysis as the division of labour in pin manufacturing and the great increase in the quantity of work that results. The next chapter in the story concerns the smelting of zinc, known as spelter, which was carried out at 3 sites: at Champion's Warmley Works, at Crew's Hole, and at James Emerson's works at Hannam. Angerstein recorded in his journal a description of the various works at Crew's Hole, stating that here there is also a spelter furnace, made to the design invented by Mr. Champion, and out into operation at the Warmley Works as long ago as 15 to 18 years ago. The furnace is built just like a glass furnace and is fired in the same way with pit coal as commonly done in this locality. Angerstein obviously gained entry into the spelter works, for his diary also includes a sketch of the inside of the furnace. Brass was originally made by heating copper in the presence of calamine, a process known as cementation. Calamine is a zinc ore, zinc carbonate, and whilst it was known that brass could be made by cementation, the role of zinc was not understood. William Champion's breakthrough came with the realisation that residual traces of metallic zinc were plated out on the inside of the cementation furnaces. Champion therefore sought to capture the metallic zinc to enable the direct alloy of the metals to produce a better quality brass, a process known as speltering, and hence the metallic zinc was known as spelter. William Champion was granted a patent in 1738 for his spelter furnace, the perfection of which had taken 6 years. Angerstein reported that he observed 5 such furnaces at Warmley, which had risen to 6 by 1761. The construction of the furnace was a closely guarded secret, hence few drawings have survived from the 1700s. The earliest detailed drawing we have of a smelter furnace dates from 1825, produced by Francois-Dominique Musselman. Musselman was a Belgian banker who acquired the then insolvent zinc mining and smelting company at Kelmis. Musselman's predecessor, Jean-Jacques Donny, had visited Bristol clandestinely in 1804, where he observed the furnaces, which he then copied at Kelmis. The principle of operation was as follows. A mixture of calamine and charcoal was packed into a special crucible, sealed at the top, but with an iron tube passing through the base of the crucible into a bath of water below. When the furnace was fired, the charcoal burnt, creating carbon dioxide, which created an inert atmosphere inside the crucible. Further heating caused metallic zinc to be released in a vapour, which was prevented from oxidising by the inert atmosphere. The vapour then passed down the pipe into a quench bath, where it crystallised as pellets of metallic zinc. The Walmley works were expanded through the 1760s, which demanded additional capital. And in 1767, the company sought a charter of incorporation, enabling the raising of transferable shares, but which required parliamentary approval. With the new capital, the Walmley Company would have been twice the size of the Bristol Company, and concerns were raised that the company would develop into a monopoly. Opposition to the move was successful, so blocking the charter of incorporation. Without additional capital, collapse of the company was inevitable. And to compound the situation, Champion tried to withdraw part of his capital without permission, as a result of which he was dismissed by his partners. And in 1769, Champion was declared bankrupt, and the works offered for sale. James Emerson had been the manager of Champion Spelter Works. In 1771, following Champion's bankruptcy, Emerson bought an estate and colliery in Hanham, previously owned by the Bristol Brass Company, and established a spelter works using furnaces of Champion's design. Emerson continued to develop the processes, obtaining a patent in 1788 for a new method of making brass with copper and spelter, his brass being described as one of the finest in the world and resembling gold. However, by the early 19th century, Emerson was in financial difficulty and was declared bankrupt in 1803. The works were sold by auction in June of that year, described as including 2 calamine houses, 4 spelter furnaces and 4 brass furnaces. The works were bought by Christopher Pope, who successfully operated the works for the next 29 years, but by 1832 Pope was also in financial difficulty and was declared bankrupt. The works were eventually sold by auction in 1838 and did not operate again. We lastly turned to the rolling of sheet brass, with particular reference to developments at Salford Mill in the 1760s. Salford Mill, seen in this photograph taken about 1930, shortly after brass production had ceased, had been acquired by the Bristol Brass Company in 1721. The mill was originally used as a battery mill, housing 12 hammers in 3 workshops, the mill being in this configuration when Angerstein visited in 1754. The postulated configuration of the early battery mill was 3 water wheels, each driving 4 hammers. But an inventory of 1859 indicates that the mill underwent a major modification in the later 1700s, and by the early 1800s the mill housed only 2 battery mills, each consisting of a water wheel driving 3 hammers, but the mill also contained a rolling mill, comprising 2 sets of rolls driven by 2 water wheels. The question is, what were the drivers for such a major capital investment? One driver was the demand for sheet metal for sheathing ships. Merchant ships making the passage from Britain to West Africa and onwards to the Caribbean, and ships of the Royal Navy protecting trade in the Caribbean, were attacked by the Teredo Navalis shipworm, which riddled the ship's hull, making the vessel unseaworthy within a few seasons. In 1761, the Royal Navy experimented with sheathing the frigate HMS Alarm with copper, which not only prevented the worm from boring into the hull, but also prevented the growth of barnacles and weed, which limited the ship's speed. Bristol-built ships quickly followed suit, one such ship being the copper-bottomed Hester, built in 1768. The Hester was engaged in the triangular trade. One such voyage in 1788 from Bristol to Anamabo on the Gold Coast of Africa and almost to the Jamaica resulted in the transportation of 320 enslaved people. The Bristol Brass Company had been operating rolls since the early 1700s as part of the wire production process, a set of narrow bed rolls being used to produce coils of brass strip from slabs of cast brass. Angerstein also recorded the use of narrow bed water-driven rolls in Birmingham for the production of sheet iron. The advance made at Salford was to introduce wide bed rolls able to produce large sheets of metal by cold rolling. The inventory of 1859 recorded the mill containing two sets of rolls, a set of breaking-in rolls with a bed of 1.7 metres and a narrower set of finishing rolls with a bed of 1 metre. The configuration of the rolls was probably similar to the strip rolls at Keynsham. We also have archaeological evidence at Salford of the location of the water wheels, the bearing mounts and the lifting eyes secured to a roof truss. Based upon this evidence, a replica set of rolls has been built in the mill to explain their operation. The sheet metal would have been cold rolled, which, as with hollowware and wire, would have required periodic annealing, there being 4 annealing furnaces on the site. The fortunes of the Bristol Brass Industry throughout the 18th century mirrored the exports of copper and brass to Africa, as shown in this graph. Superimposed on the graph, we can see the creation of the Walmley Brass Company, the bankruptcy of William Champion, the acquisition of the Walmley assets by the Bristol Company, and the restructuring of the Bristol Company under the Harford family in the 1780s. The graph also shows the rapid decline of exports to Africa as a consequence of the Slave Trade Act of 1807, which prohibited trading for slaves throughout the British Empire, and the fortunes of the Bristol Company followed the same trend. Production peaked in the 1790s, but declined rapidly in the early 1800s as the export demand for brass collapsed. At the same time, Birmingham rose in ascendancy as the centre of the English brass industry, fuelled by the Industrial Revolution and the production of hinges, buckles, buttons, hooks and other household goods, collectively known as Birmingham toys. Indeed, in 1777, Edmund Burke, the statesman, philosopher and Member of Parliament, described Birmingham as the great toy shop of Europe. There was a consequent contraction in the copper, brass and spelter industry in the Avon Valley. Woodbury Mill was described as derelict by the 1790s. In 1809, the manufacture of copper and brass ceased at Walmley. Weston Mill was sold in 1811, being adapted for making edge tools. In 1814, the Bristol Company moved their headquarters from Baptist Mills to Avon Mill in Keynsham, following which Baptist Mills was abandoned. Bitton Mill was closed in 1825, and the Cruise Hole Copper Smelting Works were sold in 1828. The Bristol Company's works were leased to Charles Ludlow Walker in 1836, but continues to operate under the name of Harford's. The Hannam Spelter Works closed in 1838, and the Kelston Mills were closed in the 1840s. Leaving just Avon Mill as the Bristol Brass Company's headquarters and Wire Drawing Mill, Down Mill engaged in brass battery, and Salford Mill engaged in brass battery and rolling. The demand for hollowware was limited, and the Bristol Company focused the output of their battery mills on the domestic and agricultural markets, a particular product being large milk pans for separating curds and whey. But Down Mill was sold in the 1870s, leaving just Avon Mill engaged in wire drawing, and Salford Mill focused on battery and sheet rolling. Batteries ceased in 1908, leaving just wire drawing and sheet metal production, which continued until 1925 when the brass companies ceased trading. The industry had gone full circle, and visitors to Salford Brass Mill today are surprised that Bristol had once been a world leader in the production of brass. But traces of the industry can still be found. Salford Mill and the Walmley site with its pin factory are scheduled monuments, and the shells of 2 annealing furnaces can be seen at Kelston Mill, across the river from the Jolly Sailor pub. The manager's house and part of the old Avon Mill still stand in Keynsham, the old mill building being incorporated into the Brass Mill pub. The pleasure rooms and offices of William Reeve, the manager of Cruise Hole Copper Works, constructed from copper slag blocks, have survived as the Grade 1 listed Black Castle pub at Brislington. And copper slag blocks are incorporated into numerous walls around Bristol, in particular around the copper smelting works at Conham, Cruise Hole and Warmley. And occasionally a street name betrays the existence of a former site, such as Brass Mill Lane in Lower Weston, running alongside the Western Cut, past the Locksbrook Inn and leading to the site of Weston Brass Mill. I hope that you found this talk informative. If you wish to know more about Salford Brass Mill, or the Bristol Brass Industry in general, please visit our website at www.brassmill.com. The Salford Brass Mill project is a registered charity, and the mill is maintained by a small group of volunteers, who also open the mill to visitors, provide interpretive displays in the mill, and deliver talks on the mill and the history of the brass industry in general to local interest groups. Please visit our website to find details of other talks in the series and background papers describing the industry and the process involved in more detail. Thank you for your time.